Hi, in this video we will talk about a controversial topic, whether median is really equal to 50th percentile, because in some texts and some online resources you will see that people are demanding that median is always equal to 50th percentile. Now, what is the meaning of 50th percentile actually? The definition says that if your score is 50th percentile, then you should know that 50% of the total number of candidates or the total number of scores are behind you. Okay? Now, for example, suppose in your classroom there are 40 learners and there was an exam and you scored 65. Okay? Say out of 100, right? That means your score is actually 65%, right? Now the point is, if I say that your score, the 65, is at 50th percentile, then you should know that 50% of the learners in your classroom are behind you. That means behind your score. That means 20 learners are there whose scores are below 65. That means your score. Is it clear? So this is the meaning of 50th percentile or any other percentile. Suppose 65 is at, say, 90th percentile. If I say like this, then you should know that 90% of the total learners of these 40 learners are behind you regarding the score. Now the question is median really always equal to 50%? So that is the question. And now I will take you to some online forums where a rigorous discussion is going on between experts on this topic. So let us visit one of the websites. Well, here we go with the first website I will mention here, that is math.stackexchange.com. And here one question has been placed by Karma Peasant that proves that the median and a 50th percentile aren't always the same thing. Now you see here he has presented three cases. The first one say that there are three numbers 1, 2 and 3, and definitely the median is 2. But 2 is not a 50th percentile. He is demanding. Why? Because 2 isn't a percentile at all. It's a tertile. Okay, we agree with him that it's a tertile. So what is a tertile actually? It's a third location or the third position, every third interval of the total intervals. Okay, so every third position. So you see that it has 1/3 of data points below it. That means you see, if you have this median as 2, then only one data point is there, that is 1, which is below 2. And this 1 is actually 1/3 of the total count of the data points. So he is correct. But you see that it has 1/3 of data points below it, that means below 2, and 2/3 of the data points below or equal to it. I'm sorry, I think it will be above or equal to it, right? Well, we go to the next proof, that is the second proof he is presenting. He has taken 5 numbers, 1, 2, 3, 4 and 5, and the median is 3. That's right. But 3 is not a percentile. So he is getting it in a capital letter. Okay, he is stressing on this word, not a 50th percentile. Okay. Now, what is his justification? You see, for the inclusive definition of a percentile, that means if you include this 3, then the percentile you will get is 60th percentile, because if you include 3, then 3, 2, 1. That means there are 3 numbers out of 5 numbers, and if you convert it to percentage, then you will get 60%, right? That is why he is telling that 60th percentile is a position of this 3 if you include 3. That means if you follow the inclusive definition, right? And if you do not follow the inclusive definition, that means exclusive definition, that means you do not count this 3 now, then you will count 1 and 2, and the count is 2. So 2 out of 5, if you convert this to percentage, then you will get 40%. So if you follow this exclusive definition, then 3 is standing at 40th percentile. That means he has a justification that you can see that 3 is a median, but 3 is not a 50th percentile, right? Now let us see what he has got for us in his third proof. He is taking some numbers from 0 to 10, and his median is 5, and also the 50th percentile. Okay, but there are other 50th percentiles that aren't equal to 5, and thus aren't medians. Namely, any number in this interval, the 0, 10, for the inclusive definition, you are following the inclusive definition at percentile, and any number interval for the exclusive definition between 0 and 10. So these are the 3 proofs he has got with us, and he wants a clarification. Okay, so we can see 3 upvotes over here, and let us see. Somebody is telling that the third example is wrong. Okay, anyway, but the first and the second one is correct, isn't it? Because according to this user 65203, the third example is wrong. That means he is admitting that the first proof and the second proof, these proofs are having some logic, right? Okay, anyway, so let us proceed with what this user 65203 has for us. So for a correct definition, he is applying the CDF of the distribution, and if you apply the CDF form, that means when x is having 1, 2 and 3, the 50th percentile is 2, is demanding that because a number of 1s is less than equal to 50% by 3. Actually, the format is somewhat different. It should be number of this set by 3 is less than equal to 50%. That means number of items within this set, that is only 1, so it will be 1 by 3, and 1 by 3 is definitely less than equal to 50%. While if you include this 2, then you will get 2 numbers, your count will be 2, in that case 2 by 3, which will be greater than 50%. So the jump occurs at 2, and this is where the CDF meets the 50% horizontal. So he is following the method of this CDF, and he is getting his answer. And he is also demanding that median, the central quartile, and the 50% percentile, that is 50th quartile, are exact synonyms. You can see that, right? Now, Karma Peasant is also challenging this, that firstly, why do you think that your CDF is the only right method to find the percentiles? So here the conversation is going on. So you can have a visit to this page, and you can find out anything new if you can from these discussions. Okay. Now I will take you to another website. Well, this one is from this website, superprof.co.k. And I found these websites actually by searching in the Google engine. Okay, just I wrote the term that median is equal to 50th percentile, and Google has suggested these websites. Okay, and here you see the example they are following. What are percentiles? I will give that link below in the description, and you see that they have taken 10 scores. And they have arranged the scores, okay, in ascending order. Now, you see what they're doing. Suppose you scored 50 points. That means you are here. That means you are at the 9th position, okay. Now, they are asking you to calculate the percentile of this 50 out of these 10 students, okay. Now, you are at 90th percentile. They are demanding that. But the definition or the meaning of 90th percentile is 90% of the scores must be below 50. But here, they are demanding that 90 percentile is the proper location of this score 50. Actually, 80% of the learners here, or the 80% of the scores are below 50, right? But they are demanding 90th percentile. But you can see, in other words, they are explaining it, that 90% of the students scored lower than you did. How it is going on? So that is a question. Because you can clearly see that 80% of the scores are lower than you, right? Well, so this is one method they are following, and they have this method, what they have done. See, in this case, that means in this scenario, in this data set, there are 8 students who scored below 50. That's true. We are admitting that. Which means our score is in the 9th position. That is also true. 50 is in the 9th position. And that is true that 80% or the 8 students are scoring lesser than this 50. That means you are here, that means you. Right? Next, you take 9 and divide it by n. So your sample size is n, that is 10. So they are asking you to divide 9 by 10, not 8 by 10. And naturally, you will get 90%. So here is a doubt or a controversy. I will not say these people are wrong or something like that, because this is a controversial topic. I have already mentioned you before. So you have to decide actually which way to go or which will be better. In this scenario, I will take you to another website, and that is this. This is onlinescatbook.com, and they have mentioned 3 definitions, right? So don't worry about this. So let us see what they are talking about. See, this is a very important line they have mentioned, and the author is Professor David M. Lane. So what Professor Lane has mentioned at the beginning is that there is no universally accepted definition of a percentile. So this is very, very important, right? So what he is talking about, let us see. Suppose there is a list of scores or list of numbers arranged in order, in ascending order more specifically, and using the 65th percentile as an example, the 65th percentile can be defined as the lowest score that is greater than 65% of the scores. And that's true. That means you have, what is a 65th percentile? That means it is the lowest score below all other higher scores, which is above or which is greater than 65% of the scores. That means all the 65% of the scores are below this score, what we are talking about. That means a number which is standing at 65th percentile. And this we have learned in other resources, right? So 65th percentile means 65% of the scores are lesser than the score for which you are declaring that the score is 65th percentile, right? So that is true. So this is the way we defined it above, and we call this definition 1. Okay, that's nice. Okay, let's proceed with the second definition. 65th percentile can also be defined as the smallest score that is greater than or equal to 65% of the scores. You see, he is mentioning that greater than or equal to 65%. So the smallest score which is greater than or equal to 65%, that means this is inclusive and this is exclusive. Okay, so this one is exclusive and this one is inclusive, right? So this we will call definition 2. Now, what is the problem with this? Because these are the 2 ways you can find out the percentile, and this can lead to dramatically different results. And this difference will be more obvious if you have a relatively small data set, right? Now you just go through this and see what these things are talking about. And the video is getting longer, so I will go to the third definition, what he is suggesting. Now in the third definition, what he is suggesting is that unless otherwise specified, we refer to percentile, we will be referring to the third definition and what it talks about. See, he has taken 8 numbers. These are the numbers 3, 5, 7, 8, 9, 11, 13 and 15, and these are all arranged in ascending order. And he has mentioned the ranks also for your convenience. And notice the numbers, this ranging from 1, he is taking 1 as the lowest and the rank 8 is the highest, okay? So what he is doing, he is computing this R, the value of R, the value of rank, okay? Now if you are interested to find out the number or the score of 25th percentile, then what he is suggesting is that he is asking to get this 25 by 100 and multiply it by the total number of scores, that is 8 plus 1. Actually, you can see that he is trying to find out the first quartile, right? That means median of the first half of the median. Because if your median is here, say between 8 and 9, definitely you see the rank 1, 2, 3, 4, 5, 6, 7, 8. So median is at 5.5, isn't it? So he is going for this thing, that means 25 by 100, that means actually he is going for 1/4 of 8 plus 1, right? So that is why he is getting this 2.25. That means 2.25 is between this 2 and 3, right? Now if your R is an integer, then the corresponding score will be that percentile. That means this 25th percentile, because this is a value of P, that is a percentile you are looking for, right? And if your R is not an integer, then what he is suggesting is that you find out the difference between 7 and 5. Why? Because you see, he is asking you to get this mantissa part, that is 2, and he is getting the exponent part, that is 0.25. Now he is asking you to get this rank of IR, that means at 2, and also the score of 2 plus 1. See, so you take the score of 2 as well as the score for 2 plus 1, subtract those two scores, multiply it by this FR, there is a fraction part, and add this to the score for IR, not IR plus 1. The score for IR is 5, you see. Score for IR is 2, so the score for IR is 5. And the score for IR plus 1, that means the score for 3 is 7, right? So 7 minus 5, you take the difference, you multiply it by this 0.25, that means 25 by 100, and you add this to the lower number, that is the lower score, that is the 5, right? So add this thing. So you get the interpolation as 5.5. And you declare this 5.5 as your 25th percentile. So this is a method he has suggested. So I will show you on the slide how these things are going on, okay? We have scores here, and these scores count to 10. That means there are 10 scores. And if you go for find out the median, that is the second quartile they used to say is at n plus 1 by 2, right? Now this is 11 by 2, that is 5.5. You have got it. You have directly got it, right? So what Professor Lane has suggested, let us see. He is asking us to get this R. Now the value of R is, say, if you are interested in 50th percentile, then we will write 50 by 100 multiplied by 10 plus 1, because our data sheet is having 10 observations, right? So we will write here, in place of 25, we will write 50, and in place of 8, we will write 10, right? So we write here 50 by 100 multiplied by 10 plus 1. Now you can see, is it matching with this? Yes. Actually, he is talking about calculation of median, right? Because 50 by 100 is a 1 by 2, and it is actually 11 by 2, that is 5.5. So it is simply the calculation of median, right? Now, next, what he is suggesting? If your R is an integer, then you declare that the pth percentile is a number with a ranker. That means whatever the score corresponding to that R, so that score is that pth percentile, right? So, but in our case here, we have got a fraction. So in case of fraction, what he is suggesting? He is telling that take this IR equal to 2. So in our case, this IR will be equal to 5, this one, right? And for FR, he is asking us to take the fraction part, the exponent part. So FR in our case will be 0.5, isn't it? Next, he is asking us to get the scores for IR and IR plus 1. Now IR is 5. So 1, 2, 3, 4 and 5. So here is our IR and here is our IR plus 1. So what are the scores for IR? 49. So the corresponding score here is 49 for IR equal to 5. And for IR plus 1, the score is 53. So I am writing here 53. This is for IR plus 1. This is for IR plus 1 and this is for IR equal to 5. Right? Now 0.25, in our case it will be 0.5. So 0.5 times 7 minus 5 plus 5. So here we go, 0.5 in our case times 7 minus 5, it was in his case. In our case, it will be 53 minus 49, right? Plus 5, that means plus the lower score. Here our lower score is 49, so we go for 49. So what we get? So 0.5 times, this will be 4 and plus 49, right? And what do we get here? 0.5 times 4, that means it will give you 2 plus 49, it will give you 51, right? So in the general way, if we go like this, then this area will be your median, right? So in a simple way, what we have learned is that add this 49 plus 53 and divide those two numbers by 2 and you will get 51. We have learned these in our previous videos. In one of the previous videos, we are talking about median. So it's a simple way we can see whatever the formula or these things are talking about are simply talking about the calculation of median and its position. Nothing else. So we get 51 here. So what Professor Lane has suggested that this 5.5 what you have got, that means in his list above 5, see 3, 5, then 5.5 is coming up. So this 5.5 is at 25th percentile, and in our case this 51 is at 50th percentile, right? So 51 is at the 50th percentile means 50% of the scores are below 51, and you can clearly see that below 51 the 50% scores are there. That means this 11, 27, 31, 42 and 49, all the scores are below 51 and they are 50% of the total scores. So it's nice. So if you go for the score count below 51, you will get 5. In a straightforward way for calculation of percentile, what we have learned before, we convert this 5 to percentage. So 5 by 10, because the total score is 10. So 5 by 10, if you multiply this by 100, then you will get 50. So 50% of the scores are below 51. So 51 is really at 50th percentile. That means the median is at 50th percentile. So up to this, it's all right. Mind it, we have taken the score count as an even number. Okay. Now we will go for score count if it is odd. So the question is this always true? So let's say, suppose we have these scores and now the score count is 11. So it's odd. So go for the median, n plus 1 by 2 and 12 by 2, and that will give you 6. And if you follow the Professor Lane's formula over there mentioned on his website, then what we see, 0.5 times n plus 1, that means 11 plus 1, right? The same thing goes on here, you see, equal to 0.5 times 12, that means 6. So actually he is going for the median, right? So the median is standing at 53. So 53 is actually the median, and it is standing at the middle position, that is 6th position, I believe. Yes, it's 6th position. Okay, so 1, 2, 3, 4, 5 and 6. 6th position is coming over here. So this is also called 50th percentile. So is this true? So that is a question. Previously it was all right. Yes, we got the median as 50th percentile, but in case of this odd number of score count, whether this is true here. So the meaning should be same, that 53 is at 50th percentile means 50% of the scores must be below the score 53. That means this portion must be 50%, right? But is it 50%? You see, the score count is 5, below 53. Now if you convert this to percentage, then you will get 45.45. That means approximately 45% of the scores are below 53, not 50%. So that is the problem. So you can clearly see that 53 is at approximately 45th percentile and not at 50th percentile. Now let us see Professor Lane's website, what he is suggesting. He is telling that if your R is an integer, where is it? Yes. If R is an integer, then pth percentile is the number with rank R. That means he is asking us to directly declare this 53, this position as a 50th percentile. But by calculation it is not coming. So the controversy is there, and I will ask you to go through the websites and different books and those other resources and forums. Some of them I will mention here, what I have shown to you. All the links will be there in the description. And let me know your suggestions or your comments in the comment box. What do you suggest regarding this? That means how can we handle these kind of problems? So please write in the comment box your suggestions and your ideas regarding this problem on percentile. And in the meantime, if I come up with some resource where we can get a clear and rigid definition of percentile, then I will definitely appear to you with a new video.